Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing processes, and this presentation is particularly based on the chapter related with the casting, wherein we are trying to talk about that how the cavity that is mold is prepared using the pattern so that the suitable casting can be made with the required dimensions. So, you know that for preparing the mold, we need in case of the sand molding mold casting process, we need a pattern. So, pattern is prepared first and which will be used for making the mold. This pattern, as I have talked earlier, that can be made of the metals, can be made of wood, or it can be also be prepared of the plastics. For low volume production and for cost effective processes, the wood is commonly used for making the pattern, but the metallic patterns can also be prepared for when the large volume is to be produced, and also the good surface finish and the good dimensional control is needed. So, the patterns are basically, as I have said, these are basically models or replica of the casting to be prepared. So, it is a model or a replica which differs from the final casting which is desired due to the certain regions, and these regions basically are related with the three. There are three factors which lead to the development of the pattern which is different from the castings. One is like providing the allowances. Patterns are provided with certain allowances so that after development of the casting, after machining and to take care of certain other aspects, we get the desired casting. Second is it is provided with the if the internal details need to be made, then we have to use core, and core is to be placed in the mold cavity. So, for that purpose normally core prints are made in the pattern. So, these are the additional features which will be used to make the core seat for the core, where we can place the core in the mold cavity. So, that is basically incorporated into the pattern. And another is wherever the change in cross section is made gradual, gradual. So, normally this is done by providing the suitable fillets or and the radius of the required size, so that the abrupt change in cross section is avoided, because which cannot be very effectively replicated, or otherwise it will lead to the presence of the defects in the locations where sudden change in cross section is taking place. So, because of these three regions, we need to provide some of the fillets in the locations where sharp change in cross section is taking place. We need to provide the prints so that the seat for the core can be prepared in the mold cavity, and we need to provide the allowances so that it takes care of many aspects related with the casting. So, one by one we will be going through these aspects related with the allowances. These play very important role in development of the castings with the required size, shape, free from the defects, etc. So, basically the topic is pattern allowances. Pattern allowances will be leading to the difference in the, when these are provided, it leads these lead to the difference in the size or dimensions of pattern from the casting. So, how much difference in the size will come, that will depend upon the number of factors which will come up gradually when we will talk about the different factors. So, the difference in size comes from the different comes due to the different regions. One is like say we need to provide the shrinkage allowance, allowance. When the vertical surfaces are there with the component or with the pattern, then we need to provide draft allowance. It's common to provide the machining allowance. And then there is a distortion allowance. And one is shake allowance. So, which type of the means rationally for providing these allowances, why we need to provide these allowances, and how these allowances are provided in the pattern, that is what we will be talking one by one. So, starting with the shrinkage allowance. Which is given to the pattern. Although it depends the magnitude, total magnitude of the shrinkage allowance will depend finally on the material of the pattern. Means what material is to be used, whether it will be made of wood or it will be made of the metal. And another is the factors that affect the allowance which is provided is the size of the casting or its component or the section, and the third is the location of the surface or of the component. Like external surfaces are given different type of the shrinkage allowance than the internal surface, like hole allowance for the holes or internal features are given in different way than those for the external features and external surfaces. So, these are the factors that will come up gradually. So, we know to understand the shrinkage allowance clearly, we need to see how the castings are made. Say we need to prepare first the pattern and then the mold cavity. So, the mold cavity, if it has been prepared, and after pouring the molten metal in the mold cavity, it will be shrinking. So, let us see that the molten metal, when it is filled in the mold cavity, say it is of the dimensions 100 mm in the height and 100 mm in say this width, like this. So, gradually there will be loss of heat from the molten metal to the mold walls, and this heat loss will be leading to the reduction in temperature, and which will be causing that drop in temperature of the molten metal. So, if the molten metal is pure, then solidification will be occurring at a constant temperature, and then again drop in temperature will be taking place. But if so, this is basically cooling curve, this is temperature and here we have time. So, this is where solidification will be starting. On the other hand, if it is an alloy, then the solidification will be occurring over a range of temperature, there will be continuous drop in temperature. So, there is this range is called solidification temperature range. So, there is a continuous drop in temperature of the molten metal during the solidification. So, again the y axis we have temperature and in x axis we have time. So, due to the reduction in temperature, of the molten metal, the liquid metal first shrinks, and thereafter once so this shrinkage which is occurring due to the drop in temperature in the liquid state of the molten metal, this shrinkage is one type of the shrinkage, and to take care of this shrinkage we have the riser. So, the shrinkage of the liquid metal is taken care of by the riser, because riser is capable to feed the liquid metal to the mold cavity wherever this kind of shrinkage is occurring, and this is where. So, there is another thing, this is the drop in temperature of the liquid metal, and then there is a change in state of the liquid from the liquid to the solid. So, this also be carrying out with the this also will be occurring with a significant reduction in the volume of the metal. So, basically the two types of the shrinkages are involved here. One shrinkage is due to the transformation of the molten metal from the liquid to the solid state. So, liquid to the solid state, and this type of the shrinkage is taken care of apart from the shrinkage which is taking place in the liquid metal due to the reduction in temperature. This reduction in temperature as well as the shrinkage which is occurring due to the change in state of the metal from the liquid to the solid, this shrinkage is also taken care of by the riser. So, liquid to solid state transformation is taken care of by the riser. On the other hand, once the solidification is over, the heat is lost and the solidification is over, means we have reached to the this stage and this stage. So, further in the solid state, of the casting, the reduction in temperature will be leading to the contraction. So, like say after the solidification, the drop in temperature from means reduction in temperature from the high temperature to the room temperature. Due to this drop in temperature also the shrinkage will be occurring. So, these are the two types of the shrinkage. So, here basically we have clubbed actually the two types of shrinkages, where one shrinkage in the liquid metal occurring from the high temperature to the low temperature of the liquid metal just before the solidification, commencement of the solidification, and another shrinkage which occurs in case of the liquid to the solid state transformation, and both these are taken care of by the riser. On the other hand, once the solidification is over, then there is a reduction in temperature of the casting, and that reduction in temperature of the casting up to the room temperature causes the shrinkage in the solid state. So, there are basically, if you precisely see, there are three types of shrinkages. One which is occurring in the liquid state only, another which is occurring from the due to the transformation from the liquid to the solid state, and third is which is occurring in the solid state of the casting due to the reduction in temperature from the high temperature to the room temperature. So, this third type of the shrinkage which is occurring in the solid state. So, basically solid state shrinkage. This needs to be taken care of by the pattern allowance, and say this 100 into 100 size casting which has got solidified, and when after the solidification, when it cools down to the room temperature, this dimension which was there of the 100 by 100 just after the casting, these dimensions will reduce. So, the extent of the reduction is need to be taken care of, and accordingly we need to make the pattern of the larger size than this one, so that it can finally it can be made of the after the shrinkage it is of the 100 mm. So, depending upon the dimensions and the metal type of the metal, extent of the shrinkage will be determined. So, the final amount of the shrinkage which is occurring after reduction in temperature from the solidification to the room temperature, that shrinkage will depend upon certain factors. One is like the length of the length or the size of the casting, that particular dimensions which is being considered, and the second is the type of metal. So, for this we need to consider one example. We will talk about the kind of the factors which will be affecting the shrinkage. Shrinkage is always given, shrinkage allowance is given to the linear dimensions. So, shrinkage allowance is given for the linear dimensions of the pattern, that is what we will try to understand through certain examples as well as numerical values. So, here if we see most of the metals shrink on the reduction in the temperature, and the extent of reduction in dimensions due to the solid state shrinkage depends upon the type of metal. So, the most of the commonly used cast metals which are used for the casting, like grey cast iron. So, we will be writing about the allowances, type of metal and the extent of the allowance, shrinkage allowance which is given. So, here it is like this, this is say in mm. So, shrinkage allowance per so this is on the linear dimensions. So, say for grey cast iron it is of 0.0105 per mm. Then white cast iron, it is given in the range of 0.016 to the 0.023 per mm. Plain carbon steel, this is given of the 0.021 So, for chromium steel it is of 0.02 per mm. For aluminum it is 0.013. For aluminum bronze it is a 0.02 to 0.023, and lead, and for the lead it is 0.026. Similarly, for the magnesium it is 0.013. For magnesium alloys it is 0.016, and for the zinc it is 0.012, 0.013. So, these are this is the extent of the shrinkage which occurs in the solid state for linear dimensions, and that is why it is expressed that this is the extent of reduction per mm. So, if we take some example to consider the shrinkage allowance, how it is given, that is what we will try to see. So, considering, and this is an example wherein these dimensions so here the height is say 100 mm, and this width is 150 mm, and this dimension is 200 mm. So, these are the three dimensions: height, width, or you can say thickness, width and length, like that. Now, if it is having one central hole like this, then we can show this manner in the front view, where in this dimension is 100 mm and this hole is of 80 mm. So, how to give, and this dimension is say 200 mm. So, if you have to provide the shrinkage allowance, considering that the pattern is made of the aluminum, so for which shrinkage allowance is 0.021 mm per mm. So, considering this, if you have to give the allowance to the linear dimensions, so it will be simply like, say, for this height, for this height 100 mm. So, shrinkage allowance will be like 100 multiplied by 0.021. So, the net dimension is 2.1. So, the total this height will be of the will be added with the extra 100 plus 2.1. So, net height which will be given to the pattern will be of 102.1 mm. Similarly, for the width, we can say this 200 mm dimension, 200 dimension shrinkage allowance will be 200 into 0.021. So, it will be 4.2 mm, and the total final dimensions will be like 200 plus 4.2 mm. So, this is mm. So, 204.2 mm. So, this dimension will be further revised. So, and its this width will be 204.2 after giving the shrinkage allowance, and this dimension will be like 102.1. Okay. Now we similarly we can give it for this the dimensions 150. So, 150 multiplied by 0.021, this will give us the shrinkage allowance, and that is to be added with 150 plus 150 into 0.021. So, this will be the modified dimension, and it comes out to be after modification, means after adding the shrinkage allowance, it will be 153.2 mm. So, this is how the dimension shrinkage allowance is given to the external dimensions. Now, if you have to see, we know that if the initially the size of the hole is, diameter of the hole is 80 mm. So, we know that when the molten metal shrinks, then there will be increase in size of the hole. So, it is given negatively, and so if the dimension of the 80 mm is to be achieved, then it will be added to the linear dimensions and the hole size is to be reduced. So, for that purpose, basically the shrinkage allowance will come out to be 80 multiplied by 0.02. So, this will give us the value of 1.7 mm. So, 1.7 mm, and this is to be reduced. So, we need to actually make the pattern of the smaller in diameter. Why? So, after adding the shrinkage allowance, the 80 minus 1.7, this will give us 78 78.3. So basically the pattern which is to be made means this whole dimension will be of, after adding the shrinkage allowance, this will be of like say 1.7 equal to the 78.3. So this is added negatively for the internal dimensions, internal like holes, and for external dimensions it is added positively, so that the dimension, it will be gaining the dimensions extra, while in case of the internal features like holes, if they are to be incorporated, then it will be leading to the reduction in the size of the hole which is to be made. So this will be basically the pattern dimension. Pattern dimension is the core dimension. The core dimension is to be reduced by 1.7 mm, so that after the shrinkage of the molten metal, in large size hole is achieved to get the desired dimensions of the hole. Now coming to the another, now one more thing, that if the pattern is made of, for in case of the wood we can use these modified dimensions after adding the shrinkage allowance directly, but if the pattern is made of the aluminum or any other metal, then in that case we have to add the another allowance, and for that purpose, say we have made this pattern of wood in the first stage, and final pattern is to be made of the, if the final pattern is to be made of the aluminum, then again another allowance is to be given. So say modified dimensions are like this, where this dimension is 204.2 and this dimension is 10. This dimension is 2.1 mm, and this is the reduced size of the hole, and it is of the 78.3 mm. Say these are the three dimensions in the front view we have taken of the earlier one. So these are the dimensions which we have got after applying the shrinkage allowance if the pattern is to be made of the wood. But if the pattern is to be made of the aluminum, then again the aluminum pattern is to be made by the casting process, and that is why the double shrinkage allowance need to be provided, and the double shrinkage allowance will be used as per the case, like what. So here we have considered initially the shrinkage allowance for the metal of the casting for making pattern of the wood. But if the pattern itself is to be made of the metal, so metal we can use for making the pattern of the different size. It can be of the steel, it can be of the bronze, it can be aluminum. So any metal can be used. So depending upon the type of metal to be used for making the pattern, so that is what will be considered for calculating the shrinkage allowance. So according to the type of the metal, the shrinkage allowance will be calculated. So instead of say aluminum, if we consider the any other metal like say the magnesium, if this is the pattern of the wood which was consider that this pattern was made of the wood. Now we have to make the pattern of the metal made of the magnesium using so again we have to make the shrinkage allowance, we have to provide the shrinkage allowance for the magnesium for these dimensions. So basically the double shrinkage allowance is given for metallic patterns, because in that case first of all we have to make the pattern of wood, and thereafter after the casting we will be obtaining the metallic pattern. So, the metallic pattern will be given the again the shrinkage allowance for the casting. So, the double shrinkage allowance is given. So, if we have to make the pattern of the metal, in that case these allowances, say the shrinkage allowance for the magnesium is 0.013. So, then this one will be calculated again, like say 204.2 plus 204.2 multiplied by 0.013. So, this is how this dimension will be revised, and then again this dimension need to be revised using 102.1 plus 102.1 multiplied by 0.013, and this whole is to be reduced further. So, 78.3 minus 78.3 into 0.013. So, this is how all three dimensions will be reduced in case of this. So, this will be used when first the pattern is made of wood, in this case single stage shrinkage is given, but if the pattern is to be made of the metal, then so this in case of the wood we will be considering the metal of the casting to be used, but if the pattern is to be made of the metal, in that case first of all shrinkage will be calculated, shrinkage will be calculated for the pattern material, and once the pattern is ready, then the second allowance is given for the shrinkage for the casting. So, basically two stage shrinkages need to be given if and according to the type of metal the shrinkage is considered. If the pattern is to be made of the aluminum, then first allowances will be considered for the aluminum, and if the casting is of the different metal, like say it is steel, then the allowances to the aluminum pattern will be given based on the metal of the casting which is to be made. So, this is what is there, double shrinkage allowance. So, here now I will conclude the presentation. In this presentation I have talked about basically the shrinkage allowance, and we have seen that if the pattern is to be made of the wood, then we need to provide the one stage shrinkage allowance considering the metal of the casting, and if the pattern is to be made of the metal, then two stage shrinkage is provided, wherein first of all we consider the shrinkage of the metal of the pattern, and once the dimensions are identified, thereafter we consider the shrinkage of the metal of the castings which is to be made. So, accordingly we have to modify the design of the pattern and the dimensions of the pattern considering the shrinkage aspect for the casting. Thank you for your attention.